Hello, and thank you for joining us. Today's webinar topic is Selecting the Best Mercury Analysis Technique for Your Application, presented by Sarah Kennedy, Applications Chemist for Teledyne Leeman Labs. We will be taking questions. You can submit questions directly using the question feature or email Sarah. She will respond to questions individually. This webinar is being recorded and will be available within a few days. Okay, now I'm going to turn it over to our presenter, Sarah Kennedy.
Thank you, Shelley. I am Sarah Kennedy. I'm the Applications Chemist here at Teledyne Leeman Labs, and today I'll take you through our practical guide for selecting the best Mercury analysis technique for your application. I'll go through the 5 most important questions to consider when selecting a technique. Then we'll learn about 3 of our popular instruments. So first I'll go through the techniques, and then you can decide which type of analysis will work best for your laboratory. As Shelley mentioned, be sure to submit questions as we go along, and I'll be able to answer them by email. So selecting the right technique ultimately depends on your specific analytical needs. For many laboratories, especially those in the environmental sector, the decision will be driven solely by the need to comply with a specific regulatory method. So if you don't need to follow a regulatory method, then your driving force for your decision will more likely be criteria like, what is the characteristics of your sample matrix? What detection limit do you need to reach? Whether you prefer to digest your samples, and any budgetary considerations you have. So these are our 5 essential questions that we'll keep referring back to throughout the presentation. So our first question, how do regulations impact your technique choice? So when you look at which instrument you need, or which technologies you want to use for mercury determination, you'll find there are a lot of regulations controlling the monitoring of mercury. So each method will state which technique is required or acceptable. So this table shows a wide variety of mercury methods and which technique they fall under. So what are the characteristics of your sample matrix? If your sample is a liquid, like wastewater or drinking water, then you will most likely be best served by one of the chemical reduction techniques, like cold vapor atomic absorption or cold vapor atomic fluorescence. If your sample is a solid, you have the choice of digesting the sample and then analyzing by atomic absorption or atomic fluorescence, or you can eliminate the sample pretreatment altogether and employ direct analysis by thermal decomposition. There are some other factors to consider. For example, the homogeneity of the sample, or known interferences like iodine or gold. And we can also run volatile hydrocarbons, which is kind of a unique matrix in itself. So some solid samples might need to be digested, and some liquid samples might be better using direct combustion. So it's really important to think about your sample characteristics when you're deciding on a technique. So if your sample is a liquid, then detection limit requirements will drive your decision. So our quick trace M7600, which uses cold vapor atomic absorption, will provide a detection limit at less than 0.5 nanograms per liter. Cold vapor atomic fluorescence, using the quick trace M8000 instrument, will provide even lower detection limits at less than 0.5 nanograms per liter when using single gold trap modes. And combustion atomic absorption has an instrument detection limit at less than 0.001 nanograms. But it's important to note that this value is from a mass-based analysis. So aqueous samples ran on this type of system will have an increased detection limit, simply because the amount of mercury found in an aqueous sample is inherently more dilute than that of a solid sample. So it's important to keep in mind. Do you have a digestion procedure in place? So the digestion process for most aqueous samples is straightforward, and laboratories often have all the equipment necessary to perform this task already. Some laboratories split digested samples with other instruments like ICP-MS or ICP-OES, so sometimes it's just more practical to share samples. Or if you know your sample cannot be easily homogenized, then direct analysis can be inaccurate. So digestion of a larger sample size and then running on a reduction method is the safest route to ensure results that you're confident in. and of course any budgetary considerations. So cold vapor atomic absorption is going to be the most economical choice in most markets, followed by cold vapor atomic fluorescence. So this has the best detection limits and the widest dynamic range for aqueous samples. You should also compare it to the cost and the wait time of sending samples out for this type of analysis if you don't already use it in your laboratory. In combustion atomic absorption, the simplicity of this method is appealing. It also will help with your green initiatives in your laboratory, but it is a higher initial investment. So it provides advantages over time. So there's no sample digestion. You don't need to buy strong mineral acids or expensive reducing agents like stannous chloride. There's no hazardous liquid waste generated that could be costly to have removed. So some of those will add up to savings. As well, with no wet chemistry prep, it also frees up your lab analyst time. So, and we all know that's valuable. So what technique is right for your application? So now that we've gone through the 5 essential questions, I hope you've considered each of them for your laboratory situation. So keep those in the back of your mind as we highlight our most popular instrument for each of those techniques. This is kind of a family portrait of our Mercury instruments here at Teledyne Leeman Lab. So first up, we have the Quick Trace M7600. This operates by chemical reduction of the sample, followed by cold vapor atomic absorption. So it can measure mercury in the sub-nanogram per liter to high microgram per liter ranges. Then we have the Quick Trace M8000. So this also operates by detecting mercury in aqueous samples by chemical reduction, but it has the option to pre-concentrate the mercury using gold trap amalgamation, and it's followed by cold vapor atomic fluorescence. And last but not least, we have the Hydra 2C. This operates by thermal decomposition of the sample, followed by gold trap amalgamation and atomic absorption. So it's best utilized for solid samples and typically requires no sample pretreatment. So let's start with the M7600. So here it is. It's modeled after a desktop computer tower, so it takes up very little benchtop space. Here it is paired with the optional ASX560 auto sampler by Teledyne CTAC to automate sample introduction. So let's take a look at some of the key benefits and features of this instrument. The Quick Trace M7600 is the industry leader for mercury detection by cold vapor atomic absorption. It's trusted by large lab networks throughout the US and Europe. We have preloaded common method templates built into the software, so analysts can just press go. This instrument will also help support your green chemistry initiative. So we've created a small inner diameter tubing harness that reduces sample consumption, reduces reagent usage, and liquid waste generation. We have developed methods using those tubing harnesses that are very efficient. They're only about 70 seconds a sample in peak area mode. So at that rate, you could run almost 50 samples in an hour. And you get all the benefits from the reduced chemical usage. And another key benefit is its flexibility. So this is our most versatile system. So while it has common methods preloaded into the software, like I mentioned before, it's easy to adapt the usable ranges by making adjustments in the software. So there's no hardware changes needed. This is great for academia and research labs. And also the Quick Trace software itself that runs the instrument is very flexible, has multiple pathways to guide you through the user interface. It's very intuitive, but it's also customizable. So let's dive into some specific features that set this instrument apart. So first we have our gas liquid separator, our GLS. It has a frosted center post design. This provides a large surface area to liquid volume, which allows for rapid evaporation of the mercury vapor from the sample. That stable, thin film over the post provides reproducible signals and precise results. It's non-bubbling, it's non-foaming, and it also has overflow prevention built right into the mount. Next is the peristaltic pump. It's a 12-roller, 4-channel peristaltic pump. It's top of the line. It's the same kind that's used in high-end ICP instruments. It also provides very stable liquid uptake, so that helps contribute to those reproducible signals. This instrument has true double beam optics, so it has a superior baseline stability. The detector compartment is thermally stabilized. We also have a feedback monitor that will make automatic adjustments to lamp energy for stability throughout the lifetime of the lamp. This is important because it keeps your IBL constant even as your lamp ages. Green initiative, I mentioned this a little bit before, but using our green chemistry tubing harness, you can reduce the total waste generated by about 40%. It also reduces stannous chloride reagent uptake by 53%, which if you buy stannous chloride, you know how expensive it is. So that can add up to substantial savings over time. The Quick Tray software is extremely flexible and intuitive. It has advanced contamination controls, overrange detection, and smart rinse features built right in. It offers tracking of consumables and maintenance tasks and will alert you when they need done. And one of my favorite features is that the worksheet files can be emailed directly. So you can send them to your team members, you can send them to our service team if you need method development help or system troubleshooting. It makes it really easy. And speaking of our service team, we have unparalleled no-hassle support team. So we're available anytime to help with troubleshooting, method development, spare parts, training opportunities, whatever you need, we're here for you. So we will never just install your instrument in the lab and walk away. Getting your business is just the beginning of that relationship for us. We want you to be successful. So let's talk a little bit more about the flexibility of the M7600. So it has a low detection limit, 0.5 nanograms per liter. It also has a wide dynamic range, about 3 orders of magnitude. It can go up to 4, but most people don't use that on a regular basis. And also the green chemistry tubing shifts the range up a little bit, so it goes from 0.7 nanograms per liter up to 700 ppb. That's really nice. And if you want to read more about the validation of the green chemistry tubing setup, you can check out App Note 1905 on our website. So again, it's easy to adapt the usable ranges of this instrument by making changes in the software. So by simply changing the pump rate, the sample uptake, and the gas flow, one of those, all 3 of those, it's up to you. You can change the response range of the instrument to fit your application. So here's the flow path and some of the theory of operation behind the M7600. So the sample and reagents flow to the GLS by the peristaltic pump. The stannous chloride mixes with the sample and reduces any mercury in the +2 valence state to its elemental form, mercury 0, while they travel to the GLS. So the liquid mix flows over the center post. The carrier gas then flows to the GLS by the reference valve and sweeps around the center post. This sweeps the mercury vapor into the Nafion dryer and removes the water vapor from the gas stream. And then the dry mercury vapor flows into the sample cell to be detected by absorbance with an incident light source of 253.652. So here is a typical 100 ppt peak profile. So here are the settings on the left for the instrument. And you can see we get this beautiful plateau where our peak is integrated across the maximum peak height. And it comes all the way back down to the baseline in about 2 minutes and 45 seconds. And you can see the replicate of those integrations is only 0.2%. So is cold vapor atomic absorption in the M7600 right for your application? So only you know that. So do you need to reach any of these regulatory methods? Do you run solids or liquids that need to be digested? Do you need a detection limit less than 0.5 nanograms per liter? And also, is it in your budget? This is our most economical CVAA system in most markets. So let's go ahead to the M8000. So this setup utilizes a platform. You can see the ASX 560 auto sampler is on top of that, and then there's an enclosure around the auto sampler. So it has this stackable design that just sits perfectly on top of each other. So it helps reduce the footprint on your desktop, and also just looks nice and clean and sharp. So what benefits set this apart from other instruments? So foremost is the ultratrace analysis. This instrument can reach levels as low as 50 picograms per liter when utilizing gold trap amalgamation mode. So it's made to satisfy the lower and lower limits required for clean water analysis. It also has ambient air control. So since this instrument does use pre-concentration of mercury on a gold trap, mitigating mercury contamination from the lab environment is very important. So this system has intuitive gas controls that eliminate air infusion onto the gold trap during the sample probe movement. So ambient air is diverted away from the gold trap, and any mercury contamination in that air goes to vent. So it doesn't have an additive effect on the sample. It's also very versatile. So while we really, boast about those ultra-low detection limits, it's versatile enough to analyze samples greater than 400 micrograms per liter without dilution. And this is because it has 3 modes. You have regular continuous flow, CVAF, which is for those higher level samples, and then single or double gold trap amalgamation modes as well. You have access to all 3 of those modes in the software. There's no hardware changes or tubing configuration changes, so you can switch them out as you need. So just like the M7600, this instrument features the gas liquid separator with the center post design, the top of the line peristaltic pump, and the reliable quick trace software. It also has 3 modes of operation: continuous flow, CVAF, single or gold trap pre-concentration, followed by CVAF. And again, there's no need to make any hardware or tubing changes to use any of these modes. They're selected in the software. And one of the biggest features is that this instrument can meet those low detection limits required for methods that are used to satisfy the Clean Water Act regulations. Again, it's easy to adapt the usable ranges of these instruments. So this instrument has 4 variables, so pump rate, sample uptake, and gas flow, like the M7600. But it also has the option to lower the PMT voltage, which reduces the overall sensitivity of the instrument and can decrease the response. So you can change the range to fit your application. So typically this instrument can detect between 0.05 nanograms per liter up to more than 400 micrograms per liter. So here is the flow path for the M8000 and some theory of operation. So it operates by cold vapor atomic fluorescence, as I've said. So we're going to digest our samples, to get the mercury into the +2 valent state. Then we're going to reduce that to elemental mercury by sodium chlorhydride or stannous chloride, depending on your method. And then we'll detect it with an incident light source at 253.652. And atomic fluorescence is the signal measured at 90 degrees from the light source. So let's start with our carrier gas flow, which is a high purity argon. So our carrier gas flow is controlled by a series of restrictors and valves. So depending on the mode of analysis, you'll run at 15 psi or 35 psi. And then the GLS is supplied from V4, while the gold trap is supplied via V5. So here's the flow path. So the sample and reagent flow from the GLS to the peristaltic pump, and then on, the sample and reagent flow to the GLS by the peristaltic pump. The stannous chloride mixes with the sample and reduces any mercury into its elemental form while they travel to the GLS. That liquid then flows over the center post. The carrier gas flows towards the DLS and sweeps around the center post. So it takes that elemental mercury vapor into the Nafion dryer, which removes the water vapor from the gas stream. The dry mercury vapor flows into valve 1. In non-gold mode, which is continuous flow, the gas will flow from V1 to V3 and then on to the atomic fluorescence detector. In gold trap analysis mode, the gas will flow from V1 to V3 during that ambient air control time I mentioned before, and then it will switch from V1 to V2. So this will load the gold trap with the mercury from the sample, and once it's loaded, the trap is heated, and the concentrated mercury will flow into the atomic fluorescence detector. So here's a typical non-gold peak profile. This is 1,000 ppt. So here are the parameters on the left. And you can get this nice plateau. We're measuring our peak at the maximum peak height. So we're taking our integrations. And you can see the profile replicate is basically 0.1%. And we can do that in about 2.5 minutes. So if your lab runs US EPA 1631, then this will look very familiar to you. It's the MDL and OPR requirements for system suitability before running drinking water analysis. So this shows our data for an MDL study using 1 ppt and 0.25 ppt, which return the result of 0.5 ppt for the MDL. So I wanted to include this raw data to show you how stable this instrument is, even at those ultra trace levels. So shows the precision of the instrument. So this shows the stability and precision over time. So this took about 2 hours to run 72 samples, and it's returning an RSD of 1.9% and an average concentration of 50.64. So that's about 101% recovery. So very stable, very precise. So is cold vapor atomic fluorescence and liquid trace M8000 right for your application? So if you need to run any of these methods, 245.7, 1631, some European norm methods, ISO methods, then you will need to use atomic fluorescence. These samples can include liquids, sediments, or tissues. They will need to be digested. If your detection limit needs to be less than 0.1 for continuous flow or less than 0.05 for gold trap mode. And ultratrace analysis is a worthwhile investment in your laboratory. It's a little more expensive than atomic absorption, but you have to consider other things like sending out samples for atomic fluorescence. And if you're required to use it, then you've got to have it. So let's move right along here to the Hydra 2C. This is our last instrument to cover, and I know I'm not supposed to pick a favorite, but I think this is my favorite instrument. It's Hydra 2C. So it operates by combustion atomic absorption. So what are some advantages of using thermal decomposition? The simplicity. So you simply cannot get any simpler for solids analysis. There's no chemical pretreatment needed for solid samples. There's no digest or matrix matching needed. The analyte is weighed directly in the boat, then it's thermally decomposed in its native form. So you don't generate hazardous waste from spent samples. It's easy to prepare the sample runs on this instrument. It really is as easy as weighing samples and loading them into the auto sampler rack. It's modular design. So this system was engineered to make it easy to maintain and convert. So there's quick access to serviceable parts, like changing the gold trap and the catalyst tube. It takes less than 2 minutes, and there are no tools required to get to those parts. And also green chemistry. So this goes back to how simple this instrument is to run. So there's no need to purchase those strong mineral acids, oxidizers, expensive reducing agents, because there's no digest required. So you have no acidic aqueous waste generated compared to the other chemical reduction methods as well. So some key features. So probably the most important benefit is thermal decomposition has the ability to report accurate results regardless of differences in sample matrix. So that means you can run a wide variety of sample types on a single calibration curve and have no need for matrix matching. This instrument also has a pressure monitoring system, so it gives real-time pressure results. So this can help verify the gas flow path is complete. It also gives insight into the life of the catalyst tube. So it gives you the necessary information to feel confident that you're ready to start your analysis. It has a built-in auto sampler, so it's really easy to operate. It's all in one. So there's no need to purchase separate automation. You can just load up the sequence and hit go. So its modular design makes this system really easy to maintain. There's quick access to serviceable parts, like I mentioned before, like the gold trap and the catalyst. You don't need any tools, and it's very quick. And also the optics are very accessible, the lamp compartment. And again, you get that world-class customer support. So when is thermal decomposition the most useful? For the analysis of solid samples. So there's a wide range: soil, sediment, sludge, fish, plants, petroleum products. Any sample that's difficult to digest or is non-homogeneous. And then samples that have a known chemical interference for the chemical reduction methods, like iodine or gold. And while you can run a limited number of aqueous samples by thermal decomposition, it was really engineered for US EPA 7473 to analyze solids and semi-solids. So to run aqueous samples, it requires extra drying time, which is dependent on the sample size, the moisture content. And it also requires the use of an additional inline chemical dryer to protect the optical cells from moisture. So it's not impossible, but you do have to have extra preventative steps in place to protect your instrument. So we have direct determination of mercury. We can get down to trace level for solids and semi-solids. We can do low microgram per liter, so part per billion levels in aqueous samples. You'll need that additional drying time and that external chemical dryer. And we can do low nanogram per gram levels for petroleum and petroleum distillates. There's no time-consuming and complex sample digestion steps. There's no wet chemistry pretreatment, except for aqueous samples, there's a little bit. And you can eliminate toxic waste disposal. And it's also very fast. It only takes about 5 minutes to sample for dry solids. And again, my favorite benefit, the sample matrix independence. So you can run one calibration curve. You can use standard operating procedures, just modify your drying time. And you can run multiple sample types without any operator intervention. So here on this graphic, you can see that we ran sediment, fish tissue, and coal all on the same calibration curve. So how it works, here's some theory of operation here. So it's direct analysis, thermal decomposition, followed by atomic absorption. Our dynamic range is typically between 0.001 to 1500 nanograms. We combust the sample, which converts any mercury to mercury, elemental mercury. And then we pre-concentrate it on a gold trap. So there's no reducing agent required. The combustion takes care of all of that. So no stannous chloride, no sodium borohydride. And our incident light source is the same, 253.652. And it works in 7 steps. So we load and inject the sample into the furnace. We dry and combust it in stages. We purify the sample in the catalyst tube. We remove moisture in the Nafion dryer. We collect it on the gold trap, dilute it, and then we detect it. So our spectrometer uses two cells. So we have a split 10-inch high sensitivity cell and a 1-inch low sensitivity cell. And the use of two cells provides the best detection limit and a wider dynamic range than with a single optical cell pass. So here's a 1 nanogram per gram peak profile. So you can see the green area is the integration in the high sensitivity cell, and the purple is from the low sensitivity cell. So the green cell is about 10 times higher because it's about 10 times the length. So both are integrated for every sample, and then the software decides based on the calibration curve which to report against. So speaking of calibration curves, this shows our recommended calibration protocol. So we recommend using aqueous standards and then varying the volume to get the desired mass of mercury. For example, by using 100 microliters of the 0.001 ppm standard, we get 0.1 nanograms of mercury. And if you increase that volume to 500 microliters, you get 0.5 nanograms of mercury. So there's two variables here. By increasing the volume pipetted, we get higher weights. And by increasing the concentration of the standards, we also get higher weights. So those two factors work together. And we can get a 15-point calibration curve using only 5 intermediate standards. And typically our low range is from 0 to 50 nanograms of mercury, and our high range is 50 to 1,000 or 1,500, depending on if you have really high level samples. And I also like to include the blank in the high concentration. I feel like it helps dial in the lower end of that curve. So here's some real life analysis and a little view of the software. So here we were able to validate 3 different combustion AA methods in one sequence in one afternoon. So let's start with US EPA 7473, which is for mercury determinations in solids and solutions. So we analyzed SRM 1633C, which is a solid coal fly ash sample, and SRM 1619B, which is a residual fuel oil. So both were well within their certified limits. So that's a solid and a solution. Next, we have ASTM-D 6722, which is also verified by that coal ash sample because it's for coal and coal combustion residues. So that came in at about 102% recovery, so looking good. And then ASTM-D 7623 is validated using 7 replicates of that fuel oil reference standard. It came in at 3.94 nanograms per gram, which is well within that certified range. So we can run multiple matrices on a single calibration curve in one afternoon and meet the requirements for all 3 of these global methods. I just think that's really impressive. So is CAA right for your application? So if you need to meet any of these regulatory methods, if your samples are mainly solids and you don't want to digest them, if you need a detection limit of less than 0.001 nanograms, it is a higher initial investment budget-wise, but you get those advantages that lead to cost savings over time. So here is the family photo again. You can see the QuickTrace M7600, which is our coal vapor atomic absorption unit, the QuickTrace M8000, our coal vapor atomic fluorescence unit, and the Hydra 2C, which operates by thermal decomposition. So that concludes my presentation for today. Thank you for listening. Please feel free to reach out if you have any questions. My phone number is on there. My email is also listed. So we'll send out a link to the presentation if you would like to view it again. And yeah, again, thank you for taking the time to learn about our mercury analyzers today.